Here we will be looking at applying the 4 laws in exponents. Now, just to recap on the exponential laws, and you should be able to know them pretty well by now. So the first one is where we multiply the same base, we add the exponents. Where we divide the same base, we subtract the exponents. When we have a power to a power, we multiply the exponents. And then when we have an nth root, we divide that root with the exponent, or the root number. Now, two consequences of these laws that we also learn almost as laws as well is when you have a base with a negative exponent, we always want to end our or make our exponents positive. So if you have a negative exponent, you can just put it over 1 basically and then take the base down. Or if the base is in the denominator with a negative exponent, you can take it up to the numerator and make the exponent positive. All right, and then the next one is when we have anything to the power of 0. Anything to the power of 0 is equal to 1. Right, now the first example looks as follows. Now we can see that this looks like the law where we have to multiply the exponents. But before we do anything, if you have a bigger number or any number and you're working with exponents, always put it in its prime factors, because then it's in its exponential form basically and you can apply the laws to it. So this is 2 to the power of 3, and then a to the power of negative 3, b to the power of 12. Right, so to the power of negative 2 over 3. Okay, so what I'm going to do now is I'm just going to multiply in the exponent to each and every base. Okay, so this is then 2 to the power of 3 times by negative 2 over 3. Multiplied by a to the power of negative 3 times by negative 2 over 3, and then b 12 times by negative 2 over 3. Alright, now I can simplify this. I'm just going to treat this as fractions. When you have fractions, we can cancel the 3, this 3 with this 3, and then we're just left with negative 2, so 2 to the power of negative 2 times a. And if I put this over 1, it's also these 3, this 3 and this 3 can cancel, and a minus is a plus, so this becomes a squared. And then b, if I put this over 1, 3 can go into itself once, and into 12 4 times, so 4 times minus 2 gives me negative 8. Okay, now the next thing we can see, we have negative exponents, so I can basically, if I want to, just put this over 1 and then take the bases with the negative exponents down to the denominator. And then it will look like this, where we have a squared over 2 to the power of positive 2, b to the power of positive 8. And then the final step that I can do is just to change this back to a 4. So this is going to be a squared over 4b to the power of 8. Okay, next one. Now first step, take your numbers and change them into their prime factors. 2 to the power of 4, x to the power of negative 4, and then times by 27 is 3 to the power of 3, x to the power of 6, cubed root. Alright, now the roots, we want to get the roots in its exponential form as well. So remember, square root has an invisible 2 right there. So if you're going to put that in exponential form, you're just going to divide every base, the exponent of every base with 2. So it's going to be 4 over 2 times x, negative 4 over 2 times 3. So this becomes 3 divided by 3, and times by x, 6 divided by 3. Okay, and then we can simplify that. That becomes 2 squared, x to the power of negative 2 times by 3 to the power of 1, which I don't have to write, and then times x to the power of 2. So when I multiply the same bases, then I add my exponents. So I can just write this down here, 3x to the power of 0, minus 2 plus 2 is 0. And then anything to the power of 0 is 1. So this just becomes 2 to the power of 2 times by 3. And I can simplify that. 4 times by 3 is 12. Okay, next up. So once again, we have relatively large numbers here, but we're just going to change them. This becomes 3 to the power of 4 to the 4th root, minus, then that's 3 to the power of 4 over 2 squared, and that's all to the power of negative 1, and that's also in a square root, and then all of that is also in a bigger square root right there. Okay, now let's take this step by step. So on this side it looks pretty easy because we just have to the power of 4 and a fourth root. So if you say 4 divided by 4, it's just 1, so this just simplifies to 3. Okay, then we have that inside square root. Now when I have anything to the power of -1, like you have a fraction on the inside and you have a -1 there, if I have, for example, a over b to the power of -1, the easiest way, not to just, multiply the -1 to every base and then take all the negatives up and down, that's a long step. All you can do is just basically swap everything on the inside. So this just becomes b over a. Okay, if you have a negative exponent there, you can make it positive and swap everything on the inside. So that's what I'm going to do here. This is just going to be 2 to the power of 2 over 3 to the power of 4. Okay, now the next step is we can take this root. Now if I have, let's say I have the square root of a over b, what I can do is I can just treat it as the square root of a over the square root of b. So that's what I'm going to do here. What would happen if I just take the square root of 2 to the power of 2, the exponent will just divide by 2. So I'm going to say 2, and then 2 divided by 2 is 1, so this is just going to become 2 to the power of 1, or just 2. And then that's going to be 3 to the power of 4 divided by 2, which is just 3 squared. Okay, now we need to apply some fraction rules in order to subtract this. So if I put this over 1, this denominator is 9. So in order to subtract these, I have to change this to a 9. So multiply top and bottom to 9 so that I can add the fractions. This will then be 27 over 9 minus 2 over 9. And that becomes 25 over 9, which then becomes 5 over 3. Okay, example 4. Okay, so here's a few ways that we can do this. Now, the first thing I can see is we have this y to the power of 0. So that's something we can immediately change to 1. Then we have an option. We can basically take this down, make it positive, or we can multiply the -3 in, or we can basically swap everything on the inside. All of those would work. So you can pick any one. What I'm going to do is I'm going to first just change that to a 1. 2 to the power, times 1, so that just disappears. Minus 3 times, and this we can also simplify. This is just 9 divided by 3, so that is x to the power 3. Okay, and now what I'm going to do is I'm going to swap the inside by making this positive. So make that a positive and swap the inside. So this becomes 2 over x to the power of -2. It's still a negative because all I've done is I've just swapped the inside as it is to make that a positive, times by x to the power 3. Now I'm going to make this positive by taking the base up and then make the exponent positive. So 2 to the power 2 times x to the power of 2 cubed times x to the power 3, and then I can take my exponent in to all the bases. So 2 to the power 3 is 8, x to the power of 6 times by x to the power 3, and then we have multiply the same bases, so x to the power of 9. Okay, and then the final example, once again we have a few of larger numbers, so just put them in their prime factors. So 2 to the power of 3, x times 2 squared, the power of x plus 1, all over 2 to the power of 5x plus 3. Alright, now next I'm going to apply the law where we multiply the brackets, or power to power. So we multiply the exponents. So this is then 2 to the power of 3x times by 2 to the power of 2x plus 2. So just be careful to multiply that with both of those terms, over 2 to the power of 5x plus 3. Now when we multiply the same bases, we add their exponents. So this becomes 3x plus 2x is 5x plus 2 over 5x plus 3. When we divide the same yes, when we divide the same basis, we subtract the exponents. So this is then 2 to the power of 5x plus 2, and then we minus the bottom exponent, but we're just going to put brackets around that, 5x plus 3, okay, and then that becomes 2. So if I multiply out the negative, I get minus 5 minus 3. So 5x plus 2 minus 5x minus 3, and that just gives me 2 to the power of negative 1, and then that would give me a half.